All right, Algebra 2. We are going to be starting Unit 3.7, which is, I broke this down into two parts. This is the graphing section. So we talked about x-intercepts and y-intercepts and how to find them. And so now we're going to start looking at the graphs and some extra parts to graphing. And then the second part of Unit 3.7 is actually putting it all together and getting a graph. All right, so end behavior of a polynomial function. That talks about the arrows. Okay, so a polynomial graph, they're smooth and continuous. So there's no breaks, there's no straight lines. They're just a continuous curve from one end to the other, and there's two arrows. Okay, so there's a left arrow and a right arrow. The left or right can be pointing up or down, but there's only two arrows. Right? So if the left or right arrows are both pointing up, then the graph is going to go to positive infinity. Right? Positive infinity. And that's because the y values are getting bigger and bigger. And so you can see on this graph below that if we look at this point right here, let's say, that's negative 3, 4. And then as it continues to go in the upward direction, we get another point. Okay, we'll pick another one. And that's the y value is now 7. Right, it's like negative 3.2 comma 7. And then it just keeps going forever, and the y values are continuing to get bigger. Right? If the graph is pointing down, okay, the left arrow or the right arrow is pointing down, then it's going to negative infinity. Right? So negative infinity. And that's because the y values are getting smaller. Again, we could look over at this right arrow because we can see it's pointing down. You know, you can pick any point you want. Let's say that one right there. You know, that's close to positive 1 for the y. It's like 7, 1. And we continue to follow it down in the downward direction. Now the y value is at negative 1. And we can see down here it's like negative 4 and negative 6. So it's continuing to get smaller and smaller towards negative infinity. All right, so then the next concept is the zeros or x-intercepts of a polynomial function and their multiplicities. So the multiplicity of a polynomial function tells the number of times a particular number is a zero of a function. So a lot of times, or most times, it occurs one time. Okay, there's one x-intercept, or two x-intercepts, or three x-intercepts, but they only occur one time. Okay, if they occur more than once, then it has a multiplicity of 2, or could it be higher than just 2 also. You could have a multiplicity of 3 or 4. All right, so if the function touches, so the graph touches the x-axis, then the multiplicity is going to be an even number. It creates a bounce. All right, so if it just touches it and not crossing through the x-axis, then it has a multiplicity that's going to be an even number. All right, and we call that a bounce. So a bounce you can kind of think of if you are, let's say, inside a room and you have a ball and you throw it up against the ceiling. It'll hit the ceiling and then come back down. It won't go through the ceiling. Likewise, if you're standing, let's say, on the ground and you throw a ball at the ground, it's going to hit the ground and then bounce back up. All right, so that's called a bounce. If the function passes through the x-axis, then its multiplicity is going to be an odd number. So in most cases, for you guys, it's just going to be 1. Okay, 1 is an odd number. So that's where the graph crosses through the x-axis. All right, so in this graph below, it says the graph below has zeros, or x-intercepts, with multiplicity 1. And so they want us to tell where they are occurring with multiplicity 1. So multiplicity 1 means the graph is crossing through the x-axis. So we have to find out where is it crossing through the x-axis. So here we can see at negative 3 it crosses through. And again it crosses at 5. Right? So we can see it's passing through the x-axis, cutting through the x-axis, negative 3 and 5. Now there's a multiplicity that's 2 at 2 right here. And that's where our bounce is. Okay, so that's what a bounce looks like. Where it doesn't cross through, it just touches it and then bounces back off. So it comes up, it's like that ball hitting the ceiling, and then not crossing through, it's just touching it, and then it bounces back off. All right, and goes back in the opposite direction. All right, so here we want to state the degree and the multiplicity of each zero, okay? So multiplicity and the zeros and the degree. So the degree is on a graph is if you count up the number of slants in the graph, okay, you get the degree. And generally, this is going to work pretty much every time for you guys. So if we count up the slants, so there's 1 right there, and then 2, and it turns back around 3, right? So the degree, we'll say, is 3. All right, and then the multiplicities of each is 0. So we're going to find all the zeros, so that's where it crosses the x-axis. So we can see it crosses here, it's here, and also here. All right, so it looks like 1, 2, 3, 4. -4, so the zeros. All right, -4. And since it's crossing through the x-axis, it has a multiplicity of 1. Just like -1, it's crossing through at -1. And since it crosses through, it also has a multiplicity of 1. And then at 2 also. And it's crossing through. So each of these have a multiplicity of 1. All right, so let's look at 2. So we want to find the degree, so we count the slants of the graph. So that's 1, 1, and then 2, it turns back around, and then 3, and then 4. So this is a degree 4 polynomial. Okay, again, count your slants, and that'll tell you what the degree is. All right, so now we want to find the zeros. All right, so we can see at -2, okay, it crosses through at -2, and also at +2. We can see it crossing there also. So -2 and +2 have a multiplicity of 1. And then at 0, you can see it touches at 0. There's a bounce there. At 0, there's a multiplicity of 2. And that's because of the bounce. All right, number 3. So we're going to count up our slants for our degree. So there's 1, and turns back around, 2, 3, 4, 5, 6. So this is a degree 6 polynomial. All right, so now we want to get our zeros. So let's find all the zeros that are multiplicity 1 first. So there's 1 there, crosses through here, another one there, and there. So it looks like all of them are going to be multiplicity 1. None of them are bouncing. All right, so now we just have to approximate what the zeros are. So it looks like 1, 2, 3, 4. So -4 has a multiplicity 1. -2. Looks like about negative, we'll call it a half. It's a decimal. It's not quite -1 yet. +1, 3, and 5. Okay, so all of those have a multiplicity of 1. None of them have a multiplicity 2. All right, number 4. So we're going to count our slants. So 1, 2, 3. So this has a degree 3. Right, and then our zeros. So let's find where it crosses through the x-axis. And so it looks like +1 is crossing through with multiplicity 1. And then we have a bounce here at -2, and so that's going to be a multiplicity of 2. right? So it touches at -2, so that's a bounce. All right, number 5. All right, so we want to get our degree, and this is in factored form. So we're going to count up all our exponents, right? So we have an exponent 2 right there, plus we have an exponent 1 and another exponent 1. So we count up all our x's. That's going to get us a degree 4. Okay, so you count up your exponents when it's in factored form. All right, and then our zeros. All right, so the zeros, it looks like we have -5 and +3 with a multiplicity of 1. And then 0 from the x squared. If you set x squared equal to 0 and solve it, you're going to get 0, but because of the square, it means it occurs twice. So 0 has a multiplicity of 2. All right, so if we were looking at the graph, it would have a bounce at 0, similar to the graph of number 2, where it's bouncing off of 0. All right, and then number 6, our degree. Okay, so this is in factored form, so we count up all the exponents. All right, so we have an exponent 2 plus an exponent 1 plus another exponent 2. And so this is going to be a degree 5. All right, our zeros. Looks like +6 from the x minus 6 squared. Let's see. Let's do all the multiplicity ones first. So -7. That's the only one that's multiplicity 1. And then we have a +6 and a +8, and those are multiplicity 2. All right. And that is it. All right, so make sure that you see, given the graph or an equation in factor form, how to find the degree, and then find the zeros. All right, good luck.